All right, so let's look at a couple more examples there, still on page 27. I'm going to change the one in the book there, kind of the middle of the page. 2x plus y, the one that starts there. It's less than 1. All right, so it says less than 10, I think. Let's just do less than 1. And then 3x minus y greater than 20. Let's make it 3x minus y greater than 2. Just to chop off the zeros, just to make it less far out there. They would be fine, but I just like these better. All right. Yeah, so this is a system of inequalities. And so today and then the next time we're going to talk about systems of just equations, but today it's systems of inequalities. What that means is I've got to look at both of the lines with the shading, and to be a solution to the system, it has to work in both inequalities. So we have to get a point, or points, there's going to be several points, that work in both inequalities. All right, so that's what we're going to look at. We're going to find the points that work in both. Those are the solutions to the system. All right, so let's keep that in mind. So to figure this out, yeah, you do the graphs of both of those, and you're just going to kind of overlay them together as best we can anyway. So yeah, we're going to graph number 1, the top one. All right, and so to do that, you do the line 2x plus y equals 1, so that's y equals minus 2x plus 1, right? And so that line is pretty simple. B is 1, intercept's 1. Slope's negative 2, so that's negative 2 over 1, down 2 over 1 from that. And it doesn't have the equals to, so it's a dotted line. All right, and so shading wise, if we check 0, 0, 0 plus 0 is less than 1. Well, that's true. So now we're looking at the shading to this side of that. Now, okay, gets a little messy now because we're also going to have to do this one on that. And so that line would be, with a boundary there, would be well, subtract the 3x, and so that's minus y equals minus 3x plus 2. Then you still got the minus, so divide by negative 1, so that makes it y equals 3x minus 2. You divide those by negative 1. Yes? All right, so this one has a slope of negative 2, b of negative 2. And so its y-intercept's there. And its slope is 3, so that go up 3 over 1. And so, yeah, it kind of makes an X there with that one. And it's dotted also. So yeah, I do get kind of messy. The shading, check your 0, 0 point Now back into the inequality. 0 for x, 0 for y, so it'll be 0 minus 0. Greater than 2? I don't think so. So 0, 0 doesn't work, so I wouldn't shade this side of that line. I shade the other side, wouldn't I? So let's go this way. Yeah. So the deal is on systems, it's got to work points. We got to look for points that work in both systems, in both inequalities. Well, where would that be? That's where I got the crosshatching, isn't it? That's the points that work in both of them, because up here, I'm shaded here, but I'm not shaded with these. And in this part, I'm shaded for this one, but I'm not shaded in this one. You see what I'm saying? It's got to work in both, so that's going to be in this area right in here, isn't it? And so you might just kind of make it obvious that that's my solutions, are in this solutions to the system is going to be, make it obvious there in that little kind of triangular area, the area there. Because look, they work in both. That's what a solution to a system means. It's got to work in both. So all the points in this area here works in both. So a little messy, but it is what it is. Any questions on that? Seem to be okay. All right, so let's do another one. How about, the second one. So x plus y greater than or equal to 8. 2x plus y greater than or equal to 11. All right. And so it'll just say, solve the system. And really, in that scenario, inequalities, you're just doing it by shading. Figuring out where the shading parts overlap. Okay, so let's start with this one. The line, first of all, x plus y equals 8 would be y equals minus x plus 8. Subtract the x over. So that's here. Eight is the y-intercept. -1 is my slope. So it's -1/1. So down 1/1, put me right there. And I've got the equal to part on it. So that's a solid line. Darker here, so. But I still need to think about the shading for that line. So if I check 0, 0, back in this one now, 0 for x, 0 for y, so 0 plus 0 greater than 8. No, I don't think so. So 0, 0 doesn't work, so that means going up here at my All right, now let's do the other line, which is 2x plus y greater than or equal to 11. So that would be y equals minus 2x plus 11, right? So my b is 11, y-intercept. And then my slope is negative 2, or negative 2 over 1. So down 2 over 1. Down 2 over 1. So, and it's also on the inequality, has the equal to part, so that's also a solid line. So going solid again here. But I need the shading for that one. 0, 0. Does it work? I don't think we're in the same category as before. We got 0 greater than a positive number. That's false. So again, we're going the other side of 0, 0. So it'd be that side of that. So yeah, I'm looking at all of these for this line. So you see which are the solution. It gets a little messy, but where's my solutions to the system? Well, it's where they both overlap. And so it would be, it's not here because I don't have, one of them. So it starts here, and then it kind of V's off right here. So it's all of this. Make it obvious. Let's really shade that in. So it's everything this side of that V right there. Doesn't come into this one or this one. Here, here, and then above. How's that? Question? Gets a little messy. Yeah, it's a little easier to shade on here if you use a pencil. All right. So last but not least, there, let's do the x less than 6, y is less than or equal to -4. Is that right? I did that right? No. I just did it backwards, didn't I? X is less than 6, y greater than or equal to -4. Well, all right, so this one, we've got pretty easy lines, like this line right here is x equals 6. What do you got? What kind of line is that? Vertical? X equals a number? So you just have to do a vertical line through x equals 6. It doesn't have the equal to part, so it's a dotted line. And that one, okay, so does 0, 0 work? Well, x is 0, so you got 0 is less than 6, so 0, 0 works. So yeah, you're shading this side of that line to the left. The other line is y equals -4, which that's just the opposite we just had, right? That's a horizontal line through y is -4. So we got a horizontal line, and it has the equal to part, so that's a solid line. Come over here so I can draw a straighter line. Right through -4 there. 0, 0, 0 greater than, that's true. So we would shade the side with 0, 0 of that horizontal line, which is above, so we're going above on that one. However, putting the two together, the system, what do we got? Well, it'd be to the left of the vertical line and above the horizontal line. So it's this part in here, isn't it? It's everything above the horizontal line, but to the left of the vertical line. If we wanted to really make that obvious, we kind of erase this. You know, this part really is not a part of that. That's why it's still on my axis. And this part, so it's really just, as far as shading goes, that's all we should have shaded, is that kind of box area. It goes infinitely this way, but there you have it. Okay.